Let's read the question, class. Mechanism of a hypothetical reaction A2 plus 2B gives 2AB is given below, in which first step is the fast step and the second step is the slow step. We have to calculate the overall order of the reaction, and 4 options are given: 0, 1, 2, 3. So class, as you all are aware that to calculate the order of reaction in a multi-step reaction, we have to use a slow step. So we can say that this reaction is used to calculate order of the reaction. But also you people can see that C is not present in the reactants. So we have to calculate the value of C in terms of A2 and B. So rate is given as K C whole square. Now we can calculate the value of C using equation number 1, which is a fast step. K equilibrium is equal to C square upon A2 then B square. So the value of C square can be given as K equilibrium multiplied by A2 multiplied by B square. From this value of C square, we can find out the value of rate, which is equal to K equilibrium, then A2 and then B square. So we can combine this K as K dash, A2 and B square. We can say that the overall order of reaction will be 3, and the correct answer is option number 4. Class, let's move to our next question, which is question number 77. When initial concentration of a reactant is doubled in a reaction, its half-life period is doubled. The order of the reaction is, the options are first, 0, second and third. Students, as we all know that T half, that is the half-life period, is directly proportional to the initial concentration of the reactant only for zero order reaction. So we can simply answer this question that the order of reaction is zero order. So the correct answer is option number 2. Let's move to our next question, class. Half-life period of a first order reaction is 693 seconds. That means we are given with the half-life period, that is T half, and we have to calculate the specific rate constant of the reaction. And 4 options are given: 2 into 10 to the power minus 2 per second, 1 into 10 to the power minus 3 per second, then 2.5 into 10 to the power minus 4 per second, and the last option is 1 into 10 to the power minus 4 per second. As you all are aware, class, that for a first order reaction, the value of rate constant is given by 0.693 upon T half. And the value of T half is already given, which is 693 seconds. So we can easily calculate the value of rate constant, which is 0.693 upon 693, which is ultimately equals to 1 into 10 to the power minus 3 per second. So the correct answer is option number 2. Class, let's move to our next question, which is question number 79. Let's read the question. A hydrogen gas electrode is made at 25 degrees Celsius by dipping platinum wire in aqueous HCl solution of pH 4 and by passing hydrogen gas at 1 atm. We have to calculate the reduction potential of the electrode at 25 degrees Celsius. The given options are plus 0.118 volt, minus 0.236 volt, plus 0.059 volt, and the last option is minus 0.118 volt. For this question, class, using Nernst equation for standard hydrogen electrode, we can calculate the reduction potential of H2, which is equal to standard reduction potential of H minus 0.059 upon N log pressure of H2 upon the concentration of H ion, which can be calculated using the pH value. In this question, the pH value is given, the pressure is given, so we can calculate the value of EH plus H2, which is equal to 0 because the value of standard reduction potential of hydrogen is 0. minus 0.059. The value of N in this question is 2 log. Pressure of H2 is 1 and the concentration of HIN will be 10 to the power minus 4 whole square. Using the given equation, we can calculate the value of E H plus say H2, which is ultimately be equal to minus 0.236 volt. So the correct answer is option number 2. Let's move to our next question, class. Question number 80. Let's read it. Mass of nickel deposited at cathode by passing 9.65 amperes of current for a period of 100 minutes through molten NiCl2 is. The given options are 35.22 grams, 17.61 grams, 8.81 grams, and the last option is 22.51 grams. For this question, class, we have to use the Faraday's law, which says that mass of the substance deposited is given by Z multiplied by I multiplied by T. In this question, I represents the current which is already given, that is 9.65 ampere. T represents the time which is already given 100 minutes, but we have to convert this into seconds by multiplying 60. And Z represents equivalent mass divided by 96500, which is the Faraday's constant. So let's solve the question. The value of Z, which is the atomic mass by N factor, is 58.7. The value of N factor is 2 multiplied by 96500 multiplied by current, which is 9.65 multiplied by time, that is 100, but we have to convert this into seconds, so multiply it with 60. The value for the entire question becomes 17.61 grams. So the correct answer is answer number 2. Let's move to our next question, class.